we'll probably only have time to get a little bit into objective 1 here. So, example 1, since we don't know how to go through all of this process yet, I'm going to ask you to graph using a time-tested method that always works, graph by plotting points. It's not the easiest nor the quickest way, but it is a way that will work regardless of the type of function given. You can always plot points. The function is f of x equals 1 over x. So, we're going to make quite a long list of x, y values just to get a more accurate picture of the graph. But first we have to decide there is one particular value of x which will not work. X must not equal 0. That's part of the domain. So before you start plotting points with any function, consider its domain. Now that we know x cannot equal 0, start yelling out some points for x. 1 is going to be awesome. 1 divided by 1 is 1. So there's our very first point. Yay, that was easy. If x equals 2, then what do we get for y? 1/2 or 0.5. If x equals 3, we get 1/3. If x equals 4, obviously we're going to get 1/4. My question for you is this ever going to hit the x-axis? It's going to get as close as we can get to it without actually hitting it. Now let's go not the opposite direction yet. Let's go numbers between 0 and 1. What about 1/2? If x is 1/2. If you take 1 and divide it by 1/2, then it's 2. If you take 1 and divide it by 1/3, how many thirds are there in one whole? 3. So if you take 1 divided by 1/3, that equals 3. Now on this part of the graph, is the graph ever going to touch the y-axis? No. So what we're going to have is this kind of a shape. Now I've not drawn that really well. This piece of the graph going up to positive infinity will never go completely vertical. Why can't it, by the way, go completely vertical? It wouldn't. Two answers there, I think, where most importantly, it wouldn't be a function. If it's completely vertical, it wouldn't pass a vertical line test. And these are functions. Okay, but we're forgetting a whole bunch of numbers. What about -1? If x is -1, we get -1. If x is -2, what do we get? -1/2. If x is -3, we get -1/3. For sake of time, I think you can see what's going to happen here, this piece of the graph. Looks like that. Now I want you to put a dotted line on the x-axis, put a dotted line on the y-axis. Okay, and then this is going to be our horizontal asymptote. This right here, obviously, is the vertical asymptote. Now, underneath your graph, put a star. Vertical asymptotes. I know. The vertical asymptotes are the domain restrictions. You need to write and underline that. Domain. Wherever you have a domain restriction, that's where you're going to put a vertical asymptote. Only vertical asymptotes are domain restrictions, not horizontal asymptotes. So why did we have a vertical asymptote at x equals 0? Because that was the domain restriction. X cannot equal 0, so we put a vertical asymptote through 0. The graph can approach 0, but it doesn't cross through it because x cannot equal 0. So only example we're going to have time for here is example 1. What I want you to do is to find the vertical. Was that example 1? Example 2, you're right. Find the vertical asymptote or tote. There could be more than one. The function is f of x equals x minus 2 over x squared minus 9. What are values, or maybe there's just one, what are values of x that x cannot equal? 3 and minus 3. How is that? Well, you probably ought to write the denominator in factored form. If you factor x squared minus 9, you get x plus 3. X minus 3. That's the difference of squares. Before you leave, just write this down. Vertical asymptote. You have two of them now. X equals negative 3 and x equals positive 3.